Today we're doing 10.1 slope and parallel lines. So first up, just remember that when we have two parallel lines in the coordinate plane here, they have the same slope, right? That's how we categorize them as parallel. Their slopes are equal, whether that be 1/3 or 10 or whatever it is. So for example, here's our figure. We need to show that it's a trapezoid. So we need to show that one, AB, is going to be parallel to DC. Therefore, we can calculate the slope. You can do the calculations here, or like with subtracting the y values and the x values, or you can just count rise over run, right? So this one has a rise of 2, a run of 3, so it's 2/3. This one has a rise of 4, a run of 6, which reduces down to 2/3 as well. So they have the same slope. So that's how we can show that they're a trapezoid. Okay, let's try this one. Again, we just have to show it's a parallelogram, so is PS parallel to QR, and is PQ parallel to SR. So we have our points, and then we can simply calculate the slope of PQ. So P to Q, the rise is -2, the run is 4, so that gives us -1/2. Another way to think of that, remember, is you could start with Q and then do a run of -4 and or a rise of 1 and a run of -4. Also gives you -1/2. What's the slope of QR? QR has a rise of -4 and a run of 2. So -4 over 2 is -2. RS, so R to S, has a rise of 2 and a run of -4. Gives us -1/2 again. And then finally, SP. So what is the slope of S to P? Again, rise of 4, run of -2, so therefore the slope is -2. So do opposite sides have the same slope? Yes, therefore it is a parallelogram. Cool. See if you can do number 4 real quick. Pause here. And hopefully you got that it's a trapezoid because there's only one pair of parallel sides. I mean, it's pretty obvious to see, but okay. We can also find missing vertices this way, right? So if you're given 3 vertices and we're missing a vertice, we can calculate the line for like a parallelogram here. We could calculate the line that we need to put point C on from D to C, and we could calculate the line from B to C, and then see where they intersect. Right, so we calculate that the slope of BC is going to be 1/4. Sorry, the slope of BC is going to be 1/4. The slope of AD is going to be 1/4. This is why we worked on this in the past, was to come up with an equation of a line that goes through one of these points. So we know it goes through point D. It has a slope of what did we decide? Negative. Oh, did you use the distance? Yeah, so we could also use the distance formula too, but these ones are pretty. Once we are in the coordinate plane, the easiest way to do this is to graph the points. We know that AD has a slope of 1/4, so we can go up 1/4, 1, 2, 3, 4, put a point, and that's where point D is. So we can just say it's at 2, 4. That's probably the easiest way to do it. Okay, so we'll try this one. We can go ahead and graph these points. I'll go ahead and graph them real quick. -3, 0. -2, 4. That's Q, and then R is at 2, 2. So we have PQR, we're missing S, so S is going to be down here somewhere. Again, we can calculate the rise and the run. So the slope of this guy from here to here is 4, right? Rise of 4, run of 1. So we're going to go this way, run of -1 down to 3, 4. So we can put our point here. Again, we're just using the counting method, but this could be done algebraically without a graph. So just keep that in mind that it is possible. Yeah, okay. I'm just erasing these for your benefit if you want to copy them down. All right, see if you can do 7 and 8 real quick, and we'll check your work. Pause. Cool. So hopefully you got something that looks like this, and something that looks like this for 8. All right, 10.2 is actually real similar, except now we're dealing with perpendicular lines. What's the property with perpendicular lines? Remember, their slopes are opposite reciprocals. So the way the book defines that opposite reciprocal is that the product is -1. So if this one has a slope of, say, 3, this one needs to have a slope of -1/3, so that when you multiply them together, you get a -1 value. So let's just jump right into it. How would we do this one? We'll walk through this one together. So this one asks, show that each figure is the given type of quadrilateral. So is this a rectangle? We basically need to prove that it is not only a parallelogram, but that it's a rectangle. So we need to just show that one of these angles is 90 degrees. So we can get the slopes to prove it's a parallelogram first. So what is the slope of DE? What is the slope of GF? What is the slope of GD? And what's the slope of FE? So calculate those real quick. Pause. So hopefully you got all those slopes as correct. And then once we know that it's a parallelogram, right, all the opposite slopes are congruent, we just need to prove that one of these is 90 degrees. So does one have, or are these slopes, I guess, all of them will be 90, are they opposite reciprocals, right? If we multiply them together, do we get -1? Yes, that's how the book defends it. Or you could just state that they're opposite reciprocals as far as I'm concerned. Okay, the last bit of information, or the last skill is sometimes they give us these equations for lines, and we need to classify what type of shape that makes when you put all 4 lines together. So they throw on this added layer of difficulty by not putting the lines in a nice slope-intercept form. So our very first task here, when they give us these 4 lines, is to put it in slope-intercept form. So we just rearrange the equation. You know, here we add x to both sides and then divide by 2. Here we would subtract our 2x. Here we would divide both sides by 2. Here we would just subtract 8. So hopefully that gives them in these slope-intercept forms. And then this way, they're much more easy to graph, right? So we can graph it. We can actually just look at the slope as well. So if you look at the slope of these guys, we have this one has a slope of 1/2, this one has a slope of 1/2, this one has a slope of -2, this one has a slope of -2. So is it a parallelogram? Do opposite sides have the same slope? Yes. The other question is it a rectangle? Do opposite sides, are they congruent? Or sorry, not opposite. Are these slopes, are they opposite reciprocals of each other, right? Do we have that 90-degree angle? Is 1/2 the opposite reciprocal of -2? The answer to that one is yes as well. So that means that we have a rectangle. If we graph it out, it's pretty obvious, but we can do it without graphing. That's the point, is all we need to do is look at these slope values. But in order to look at those slopes accurately, you need to get them all in the same form of equation. Okay, let's try this one. So this guy here, the Clay Avenue one, we add 9 to both sides and then divide by 3. So that gives us 1/3 for our slope. For this guy here, we're going to subtract 2x from both sides, and then we don't have to divide by anything, but it gives us -2 for a slope. And then similarly, we get 1/3 and -2 for both of those. So we can figure out the slope of all these, right? The slope of all of them is 1/3, -2, 1/3, -2. I don't know why they feel the need to rewrite the whole thing again. So our opposite sides, do they have the same slope? Yes, so it's a parallelogram. Do those sides, are they perpendicular to each other? Are they opposite reciprocals? No, they are not. So it is not a rectangle, it is merely a parallelogram. So something like that. All right, see if you can finish that one up. Pause. And hopefully you got that it's a parallelogram because these are equal but not a rectangle because these are not opposite reciprocals. Okay, that's all I got. Good luck.